my dog called me the other day, and I knew it was him because I just got him a new caller ID. Okay. I got more laughs the second time. But
It grows on you.
anyway, so this is the second part of the fundamental theorem, and so basically what it says, if you take the antiderivative and you plug in the top limit and the bottom limit and you subtract those two things, you get the value of this is called the definite integral. When you have constants up here, it's called the definite integral. When you do not have constants up there, like the antiderivative or what we've been doing with the x's when you have a variable, that's an indefinite integral because it's not a specific quantity that you're talking about. Okay, so it tells you a way to evaluate a algebraic method for evaluating a definite integral, which back in the 1700s when they started talking, I think it was the 1700s when they started developing this stuff. No, it was before then or later. But when 1600s, okay. But they didn't have graphing. Like if they wanted to solve a problem, like how far does something go when it's dropped, if you know the acceleration formula and all that kind of stuff. They didn't have a graphing calculators where they could add up rectangles and all that kind of stuff. So now they had an algebraic method, and it was kind of an earth-shattering discovery at that point. So let's do one. I made up a couple for you because I didn't want to steal everything from the book, and my Moby's kind of messing up. I will get it back. Okay. So evaluate the integral from here's a kind of a tricky one, kind of interesting one too. I found out when I made it up. 0 to 1 of 3x squared plus e to the x e to the x dx. Right? Could you do that?
No.
No? Yeah, you could. So what is so big F, right? What's the antiderivative of 3x squared? I made it work out nice. Okay. And what's the antiderivative of e to the x? E to the x. Okay. So then what you do is so when I draw a little bar like that, it means like this. It means plug in those numbers and subtract them into that formula. Okay, yes, Joe?
I have to do like a plus C or something.
Well, you do, but the plus C, what happens to C? The C minus the C. They disappear, right? So that's why you don't have to worry about the plus C because those disappear when you subtract them. So this is equal to 1 cubed plus e to the 1, right? Did I do that right? Minus 0 cubed plus e to the 0, okay? And then you simplify, which is 1 plus e minus, what's this quantity equal to? 1, which is equal to e. Whoa, okay? So that would be the area under this curve from 0 to 1. So to show you how you do that on a graphing calculator, you want to know that, don't you?
Absolutely.
And
You only have one part of your calculator.
yeah, you should have a little part on your calculator part. I'll make like 3 or 4 questions because it's going to take place on a Tuesday. Your test.
This way part of this press upcoming.
Yeah. So
Will we get our quizzes back before the test?
yeah, I'm gonna get your quizzes back one day. Okay. So you. So what was my function in there? Y equals. So remember when you do this, okay, that you have to plug in the integram, not the integral. So you don't want to plug in what you took the integral up. I mean, you want to plug in what's in here. 3x squared plus e to the x, which is above the natural log key. 7 natural log x, and go like that. And then you don't need a big viewing window, so I'm going to go in and change your window because I don't think it will do the graphic integration without if you don't have the function within your window. So I'm going to set up my window from -1 to 2 so I can see it. I don't need to go way down to -10 because this is all positive stuff. So I'm just going to set it to -1. And then I guess I could leave that at 10. Could I leave that at 10? Let's see what I get. So you get this thing that kind of looks like a parabola, but it's kind of a box. It looks like a parabola, but it's not exactly a parabola because it's kind of being pushed up by this e to the x, and it's kind of a lopsided parabola. If you do it, and I want to go find the area, second calc 7, and lower bound, I want to go from 0 up to 1. And let's see what I get. I get 2.718, which is also known as E. Okay, so that's kind of a cool thing. So the area under that curve is actually E, which is kind of a interesting. Anything guys interesting? Sure. Okay. So I think that would be the area under the curve of, would that be the area under the curve of E as well, from 0 to 1? I think it would be. Okay, so then another type of problem that you're going to see. Okay, so what if they say, and I kind of improvised on the one in the book, so I wasn't doing the exact same thing. Find the area between the graph of f of x, or y equals x squared minus 4, and the x-axis on 0 to 4. Okay? So I've been talking about the integral as the area under the curve. Well, it's not really the area under the curve, right? Because the area between the curve implies that everything, like you can't have a negative area, right? So the integral actually takes into account that when it's negative, right? So if you have part negative area and part positive area, then you have to, if you're just trying to find the area, you have to take the absolute value of the area that's below. If they say find the area between the curve and the x-axis, area implies a positive quantity. So if I graph this, where does this thing cross the axes? Not at 4. Well, yeah, it crosses the y-axis down here at -4. But then it goes up here, right? Add 2 and -2. So the first thing you should probably do is try to, if you don't have a graphing calculator, which you might not on this part of the test, you have to graph that, and this is the point 20, right? And this is the point -20. And you know how to find the zeros, right? X squared minus 4 equals 0. So x squared equals 4, so x equals plus or minus 2. So the first thing, when you're finding area between the curves, you want to find the zeros, because that's where your area is going to change from negative to positive. So look over here. I want to go from 0 to 4. So I want to find this area, right, which is going to be, that quantity, which is going to be a negative quantity. And then I want to go from 4 up until where? Well, I mean, if I plug in 4 here, what do I get out? 4 squared is 16 minus 4. So that's a point 4, 12. All right? So I'm going to make this area green. Okay? So you want to put together this plus this, where you want to take the absolute value of that, right? And so what that entails is breaking this up into two separate integrals. Because you want to go from, first you want to go take the integral from 0 to 2, and that's going to give you a because if you just did it in one integral, it's going to subtract the negative part, you see, and it's going to give you one value. So potentially you could get like, much less area than you want to. So I want the integral from 0 to 2 of x squared minus 4, but I also want to, so I want to take the absolute value of that. Let's do that at the end. And then I want to take the integral from 2 to 4 of x squared minus 4. Whoops, don't forget your dx. Okay, dx. And so then I want to integrate both of those quantities. All right? So the first one becomes, let's see, well, they both become x cubed minus, whoops, not x cubed over 3 minus 4x. And I'm going to evaluate that from 2 to 0. And these could get a little messy because you have a 3 in the bottom and you're squaring a 2. So this quantity becomes 8/3 minus 16. Yes? 8/3 minus 6. Did I do that right? No, minus 8. Sorry. Minus 8, which gives you 8/3 minus 24/3, which is how many thirds? Negative 16/3. So this quantity, this area right here, is negative, well, it's not really the area, but the value of that integral is negative 16/3. Follow that? Okay. This one, I'm going to plug into the same thing, x cubed. Oh, and you don't have to worry about the 0, because when I plug in 0, what do I get? 0, right? So this case, I'm going to get x cubed over 3 minus 4x, evaluated from 2 to 0. Okay?
2 to 4.
2 to 4, sorry. 2 to 4. And so if I plug in 4 in here, I get 64/3 minus 16. But then from there, I have to subtract 8/3. When I subtract, I would keep your parentheses kind of like this. 8/3. 8/3. I'm plugging in 2 now. 8/3 minus 8. Oh, what I did?
Where's the 8/3? Oh, never mind.
8/3. Now I'm plugging in 2, right? Plugging in 2, and I have to subtract those. I have to subtract those two quantities. And so if I do that, that's 64/3. How many thirds is this? 48/3. So 64 minus 48 makes 16/3 minus negative 24/3, which gives you, did I mess up?
Why is it 24?
I got 32/3. Is that right? Wait. I gotta look at my math again, because I did it right last night. 16/3, and I get 64/3. 64/3 minus 16.
Isn't it 16/3?
Oh, what? 16/3. Oh, you're right. That's where I messed up. Minus 16/3, which gives you positive 32/3. Right? Right? And so now you want to add these two things together, but you want to take the absolute value of that, because you want to find the area between the curves. So even though this is negative, so you're going to take negative 16/3, the absolute value of that, plus 32/3, which gives you 48/3, which is equal to 16. Okay? And that would be the area between the two curves. Now, can I just do this on my graphing calculator? Yes, you could, but this might be a non-calculator thing. Now, how would you do that on your graphing calculator? You want to know? To check. Okay? So, you go, first you gotta make sure that you put your function in there. X squared minus 4. So I'm gonna go x squared minus 4. And I'm gonna set up a window so I can see it from, I gotta go at least from -3 up to, I guess I don't have to go that far, positive 3. But I gotta make that sure that my y goes high enough, and since I know that integral goes up to 12, I'm gonna, not 115, I'm gonna put in that 15 in there, just so I have room to see my graph. And then if I hit graph, I see my, whoops, what?
Doesn't x max have to be greater than 2?
Oh, is that what, yeah, sorry. X max has to be greater than 4. So let's set that to 5. Let's go down a little bit lower because it goes down to -4. Okay? Let's go down to -6 just in case. Now, so what you could do with this function, okay? I gotta turn my stack plots off. So this isn't going to give you the area, but what you could do is you could change this function and insert an absolute value in there. Second, insert math, go over to num, okay, see ABS, anti-lock braking system, and you plug that in, and you close the parentheses. So now, what this does, wherever the y values are negative, it's going to make that function positive. Right? So if I graph the absolute value of that function, it looks like that. Right? So instead of this going down, instead of this going down here, right, anywhere it's negative, it pops up. And then I can take the definite integral from negative, or from where was I going? From 0 to 4, right? From 0 up to 4, and then I get 16. Isn't that cool? Okay. So that's how you do it with your graphing calculator. Yes, sir.
So if you're doing it algebraically, do you want from the zeros?
Yes,
and
exactly.
then you just see if the zeros lie within your
Right.
interval, and then if they don't, then
And you have to break it apart. Yeah, you don't have to worry about it with zeros. Yes, Joe.
Do you have to the absolute
I was trying to do
Well, you don't have to do the absolute value thing. No, I mean, Next does the absolute value for you, so you can do it all in one shot. You could, I mean, if you didn't like doing that absolute value way, you could break it into 2 intervals, right? But you still have to find the zeros of the function, right? So, yeah, that's a good point. You want to, so to find the area between the curve, you want to find the zeros and then see where your integral changes from negative to positive or something like that. Okay? I'm going to go back to this thing because this is the last thing that I'm going to talk about. And this is a really fun kind of problem. And I gave a couple of these on your homework, and these are really important because I remember years ago when I was doing AP questions at CalCamp, these things come up a lot on AP tests. So you should try to understand how these types of things work. So what this is the graph of, using the graph of the f. So this is some function f, okay? But they say that h of x, another function, is the integral from a to x of f of t dt. So if this is a function, then notice that there's no equation for that function, which is a favorite thing for the AP people to give you. They give you a function without an equation, and you have to interpret things about the integral and the derivative from. So relating the graph of the integral to the area. Yes, sir.
Could you say that h of x is equal to the capital F that we were using earlier?
H of x is equal to capital F. No, okay? Because capital F is the antiderivative. That's how you would evaluate it, okay? But capital F implies that you have a function, you know, but you don't really know what the function is,
Kind of
right?
like capital F, but not a function that you know.
Well, it's a function of where you are. Well, let's just do it. Hopefully, it'll you'll come out in the wash it. Okay. So the integral h of x is defined as rectangles added up from 1 up to x. Okay. So looking at this, it says find h of 1. So this is the graph. So this thing. Hey, stop doing it. So this thing here, you're messing up my video. Where's my back?
Do you have Moby?
It's always in the same place, Mr. Leader.
Okay, you be quiet. You don't know. So this is f. Okay? This is the function f. Well, you have to. You're thinking about lots of things at the same time. Okay. So who could tell me what h of 1 is? What's h of 1? Very good. Not because the value of the function at this point is 0, right? It's because if I plugged in a 1, if my integral is going from 1 to 1, what is the area underneath the curve? 0. Not because the value of this function is 0. You understand the difference there? So it's kind of a bad question because you say, oh, it's just where the function is 0. It's not where the function is 0, it's where the integral is 0. Okay?
Well, it would be the same thing for state 3.
It would be, so if I went from, if my function were, for instance, from 3 to x, right? And I said, what is f of 3? F of 3 would not be 0, right? But h of 3 would be 0, you see? Okay, so it's that's kind of misleading kind of question. So I
Well,
should.
why is h equals to 0? Isn't there area
Yeah.
of that term?
No, I was just saying if the function, if h of x were defined as 3 to x, right, instead of 1 to x. Right? So is h of 0 positive or negative? Why? Who said it's negative? Why, Sam? Very good. So Sam correctly said that h of 0 is negative because I'm integrating from here to here, you see? So I'm finding the area under the curve, which is a positive function, but I'm going in the backwards direction, right? So it'd be, you understand? So it'd be a minus b if I were integrating and you get a negative number. Yes, sir?
So if you're underneath the graph and going backwards, it's impossible.
Yes? Okay, if it's underneath the graph and going backwards, it'll be b. Okay, so is h of s positive or negative? Negative integrating backwards equals 0. Okay, negative moving backwards or something like that. Okay, moving backwards. Find the value of x for which h of x is at a maximum. So here's another kind of tricky thing. Where would you have the most, if you start at 1, when would you have the most area under the curve?
4.
Very good. When you get to here, right? You understand that? Because if you start here, and I start adding up area, right? And then after this, what happens to my integral?
You just have to like look
But
at this.
isn't it since it's area when you take that?
No, well, it doesn't say that. Find the value for which h of x, which is the integral, not the area, but the integral, right? So you're taking into account whether it's negative or positive. Okay? So do you guys understand why 4 is the maximum of h? Because that's so now if my integral is positive, now I start subtracting stuff, right? Subtracting rectangles.
You just have to like be able to see that.
Yeah, you just have to be able to see it. Yeah. Okay? Find the value for which h of x has a minimum. What do you think by looking at the graph? Where? Very good. Over here at 8. You understand why? Because I have more area here than over here, right? So if I start here, and if I subtract this little piece, the most is going to be most negative over here. Yeah? So that would be at 8. And then lastly, this is kind of tricky. I didn't think about this. Find the x-coordinates of all points of inflection of the graph of h of x. Who thinks they could figure that out? May? Probably should pay attention.
You can't
Where?
either.
Do you have to draw the derivative of that?
Nope. You don't have to draw the derivative.
1, 3, and 6.
What?
1, 3, and 6.
Ian's a pretty smart kid, okay? Ian said correctly 1, 3, and 6. How come, Ian?
Those are missing maxes.
Yeah, but what does that tell you about, what does that tell you about the 6? Sorry. 6. So, but why?
So the derivative would be,
So here's f, right, which is the first derivative of h. Yes? F is the first derivative of h. Point of concavity, or a point of inflection occurs when the second derivative is changing from negative to positive or positive to negative. Okay? So in other words, you're trying to figure out where the slope of the derivative is changing directions. You see? So here it's decreasing. The slope, the derivative is still positive, but it's becoming less positive, right? And then so when the slope of the derivative changes, that's where you have from negative to positive, positive, negative. That's where you have a point of inflection, right? So here the slope of f prime is negative, and then right here it changes to positive. Here it's going from positive, and then it's changing negative. Here it's changing from negative, and then it's changing to positive. Do you understand that?
And that's because
Okay.
the derivative of the derivative is at 0 at that point.
Well, what's happening is so if I'm integrating, right? If I start integrating at 0, I'm gaining area, but I'm gaining area at a slower rate, and now I'm not gaining any area. Then as I go here, the rate at which I'm gaining area is increasing. And then the rate at which I'm gaining area is decreasing. And now I start losing area, and I start losing area faster and faster and faster. And then I start losing area less slowly or something like that. Okay?
I was just asking in
So-
terms of like the derivative of the derivative.
The derivative